Today we are going to discuss Miller-Rabin primality test algorithm. So this algorithm is somewhat similar to Fermat's primality test algorithm. So before going to Fermat's primality test and thereafter Miller-Rabin primality test algorithm, let us try to understand the congruence mathematics. So first, congruents are denoted by the symbol. This is the congruent symbol, and it is introduced by Carl Friedrich Gauss. So two integers are congruent to each other, then A congruent. If two integers A and B are congruent to each other, then we will write A congruent B mod n. That means A minus B will be divisible by n. So n divides the difference between A minus B. That means A minus B equal to Kn for some K which belongs to Z. Okay. So let's take one example. Let's take n equal to 7, and so we can write 3 congruent 24 mod 7. Okay, that means 3 minus 24 should be divisible by 7. 3 minus 24 is minus 21. Minus 21 is divisible by 7. Let's take another example. Minus 31 congruent 11 mod 7. That means minus 31 minus 11 should be divisible by 7. Similarly, minus 15 congruent minus 64 mod 7, we can write, that means minus 15 minus minus 64, that means plus 64 should be divided by, it should be divided by 7. That means 49 should be divided by 7. So meaning of this A congruent B mod n means A minus B should be divisible by n. Whereas in this example 5, which is not congruent 1 mod 3, because similarly 13 is not congruent to mod 7, because 13 minus 2, which is 11, is not divisible by 7. So there are some facts regarding congruence mathematics, is that any two integers are congruent modulo 1. A congruent B mod 1, which is true. Two numbers, if they're integers and they're congruent modulo 2, then both the numbers will be even or both the numbers should be odd. Okay. Now, what is Fermat's method of primality test? Fermat's primality test is a probabilistic test to determine whether a number is a probable prime or not. That is called Fermat's primality test. This primality test is actually being used in cryptography heavily. In cryptography subject, Fermat's primality test is there. Okay. So it also called Fermat's little theorem, which states that if P is prime and A is not divisible by P, then a to the power P minus 1 congruent 1 mod P. That means a to the power P minus 1, where P is prime, a to the power P minus 1 minus 1 should be divisible by P or not. Now let's dive into the original algorithm, the actual algorithm that we have started with, that is Miller-Rabin, primality test. So Miller-Rabin primality test also same thing happens. We check whether any number n is prime or not. So for that we have 3 steps. First step is, step 1 is find n minus 1 equal to 2 to the power k into m. This is the first step. So, and then second step is choose a number that lies between 1 to n minus 1. So let's say you are going to search any number, let's say 23, whether it is a prime or not. You have to choose a that A should be chosen such a way that it should lie between 1 to 1, in between 1 and 22. That means it should be less than 22, it should be greater than 1. That means 2 to 21, in between any numbers you can pick as A. First, and then step number 3, you have to calculate B0, which B0 congruent into the power m mod n, and then you have to calculate bi, which is bi minus 1 square mod n. And then if bi is plus 1, then it is composite. If bi is minus 1, then it could be probably a prime number. Now let's take an example and let us solve. Let us see an example. Let's say we are going to check if 23 is a prime number by Miller-Rabin Primality test. So based on the algorithm, what you have to do? So the first step is we have to find n minus 1 equal to 2 to the power k into m. So n minus 1 equal to 2 to the power k into m. So our n is 23. So 23 minus 1 equal to 2 to the power k into m. And here the value of k, let us consider it to be greater than 0. So 22 by 2 to the power 1 would be our first m. Okay. Therefore our m will be equal to 11. Next step is what? Next step is that we have to again 22 to the power 2 will be equal to Rm, which is equal to m will be equal to 5.5. So 5.5 is not an integer. Okay. So algorithm says that calculate this. Okay. So first you have to find this. Step number 1. Choose a such that a should lie between 1 to n minus 1. That is our second step. So here once we get this fraction here 5.5, then we'll see our previous step where the value of m is 11. Okay. So step number 1 is done. Now let us see step 2, where you have to find an a, and that a should be in between greater than 1 and less than n minus 1, and this a has to be chosen randomly. Okay. So let us choose a at equal to 15. Randomly we are choosing an a. After choosing a, we have to calculate in step number 3 b0 and then b1 and then b2, and then we have to keep seeing the value of b until bi. I mean, we'll keep going and we'll calculate b0, b1, b2 like that, and until unless we end up getting plus 1 or minus 1. Okay. So we have chosen a equal to 15 randomly. So first let us calculate b0, which is equal to a to the power m based on the formula mod 23 mod n. Okay. So here our b0 will be, so this is congruent, 15 to the power, we have calculated our m as 11, 15 to the power 11 mod 23, which is mod 23 you have to calculate. Okay. So before that, where is the stopping point? Stopping point is after choosing a, if a to the power m mod 23, if it congruent minus 1, then n is prime number. Okay, this is what we are finding. So first we will calculate B0. Okay. So B0 you have to calculate. So B0 is 15 to the power. So 15 to the power 11. 15 to the power 11 mod 23 is how much? Basically 15 square 15 square equal to 18 mod 23. Okay. Then 15 to the power 4 is congruent 18 square mod 23. Okay, let's go to the next page. 18 square mod 23, which is equal to, which is congruent to mod 23. Next, 15 to the power 8 congruent 4 mod. Now it is given as 15 to the power 11 here. 15 to the power 11. So we have calculated 15 square, calculated 15 to the power 4, calculated 15 to the power 8. So putting all this 15 to the power 8. So 15 to the power 11 congruent 15 to the power 8 into 15 square into 15, which is equal to 4 into 2 into 15 congruent 22 congruent minus 1 mod 23. So therefore it has come as a minus 1. So the algorithm says that if bi equal to plus 1, then it is composite. If bi equal to minus 1, then it is probably prime number. You can conclude that 23 is a prime number using Miller-Rabin primality test.